Hello Gophers, and welcome back to part 17 of Introduction to Go. In this video, we'll be learning about pointers, how to reference or dereference any pointer variable, which are the data structures that use pointers internally. So before we move forward, please do not forget to like, share and subscribe to our YouTube channel. Also do not forget to press the bell icon so that you don't miss on any new videos or tutorials that we put forward. Now let's start by understanding the concept behind using pointers. Now, pointers are actually the address to any variable that you might be using. Now, that variable can be a variable of type structure, map, array, slice, or any primitive data type that is int, string, or boolean. So, normally we use pointers where we want to uh, not create another memory of the same variable. So let's say I have created a big array that holds, let's say, 1,000 integer numbers. Now, if in case an int number stores 4 byte of memory, now 1,000 means 4,000 byte of memory is being used. Now, if I copy this complete 4,000 byte to another variable that creates 8,000 byte of memory, but at times you might not want to copy the complete array because you are not doing any manipulation in the array but just accessing the values. Let's say you are passing the array so that there can be a function which can add all the values or find the highest number of the array or anything of that sort, but you are not modifying, so you don't want to copy the complete values and create another memory map or a memory block for that array, so creating more memory utilization of your program. But yeah, so that's one case when I normally recommend you to use pointers so that you don't use too much of your memory of your RAM. So now let's run a program where we'll understand basics about pointers and then we'll go into deep about what data structures in Go internally are using pointers, and we'll see how they are using and with an example. Let's say I have two variables, say num1 and num2, holding value of 2 and 4. Now I'm printing the value of num1 and num2. Then I call the functions add. Now, in case you are not aware about how to use functions or how to create them, you can go to my video where I have given a tutorial on functions. Now, to get the link of that tutorial, you can click on the eye icon on the top right corner of your screen, and there I will list the link of the video. Now let's say this function add is actually accepting two integer variables a and b and would be returning an int again. And the return would be the sum of a and b. That's simple, and let's try and run this program. Now if you run this program, you can see the output which says 2 and 4 on the first line, which means this line is printed, which prints the value of num1 and num2, and then again in second line it prints num1, num2 and the sum. And if we run this output was error before I ran. So right now the output would be 6. That is obvious answer. Now let's say I go ahead in this function and I change the value of a to, let's say, 10, and then run this. So this says that the sum is 14, which is as expected because over here b is 4 and a became 10. That means the sum became 14, and that's why c is 14 and we returned 14 into sum. So it is printing 14 over here, but num1 and num2 remains unchanged. It is 2 and 4. That means any change in a, that was the first argument of add, that is num1, has no impact in actual calling function. So anything you change over in the function has no impact on the calling function. Now, how to pass an address or pointer to a function? So to do that, to access the address of any variable, you can directly go ahead and write n% sign and n% sign again. Now, a variable that you want to create to access or to store the pointer address or the memory address are always having a dereferencing sign, which is a star sign before the data type for which the pointer or the memory address has to be printed. Now, I have passed the address of num1 and num2 to this add function. That means I have passed the place where this num1 is actually storing the value 2 into the RAM. So I have given the RAM's address. Now if I change anything on that address, that means the value of num1 will also get impacted because we have changed in the address of num1. So to do that, now A being a memory address or a pointer, you cannot directly go ahead and put an integer into it because the data type is not same. To do that, you need to dereference A to access the memory location or the memory address of that. To do that, we'll use a star sign. So star A means go to the memory where memory which is stored in A, memory address of A, the value that is stored into A, that memory actual location. So that means the actual address location of num1 in our case, and go ahead and store 10 over there in and replace the 2 from there. So that means we have replaced 2 and put 10 there. Now to add star, and then again B is also a pointer, so we'll reference it as star again. Now star of A means the value that is stored in the address which is contained in variable A, and again star to B means memory the value of the memory which is stored in B. So that means the value that is stored in some num2. Now when we get run this program and see the output, your value of num1 should get changed to 10. Now if you see, before we ran the sum, the actual print was for num1 and num2, which printed 2 and 4. But now after the sum has been executed or the add has been executed, the value of num1 is also changed to 10 because we have changed this inside the function. So this is how you can use pointers. Now we have also discussed about like slices and maps, which also implement uh, pointer internally. So now let's see how we can use those, and uh, an example where you can do that and check if they are actually implementing a pointer or not. So now let's see, I have created a variable called map variable, which has a map of type string as keys and int as the values of the keys. So I have stored two keys A and B having value 1 and 2. Now I have printed the map variable first so that we can have a look of the values before we do anything to it. Then I have created a function named as add again, and in that function I have passed the map. Now if you have noticed, I have not used the pointer passing or the address passing to it. I've just passed the variable as we pass the integer normally without reference. Now what I have done is I have changed the value of A, key name A of that map, and changed it to 10, and then done some addition and return the addition of the two keys. Over here I'm trying to access the map uh, and print the value of map again, and also the sum that is returned from the function. Now let's see what happens. If you see, the value just before we execute add is 1 comma 2 of A and B respectively, but when we are executing add function, it gets changed to 10 comma 2 for A and B. Now what happens, because map is actually not an actual value type, but it's a pointer type structure in in it. It is actually holding the address of the inline structure to it, inline data to it. So that is why whenever you pass a map variable to a function, it will always pass the address to the function. Now, if you do any manipulation or anything inside the function to the actual map, then it will actually change the things in the original value that was being used in the parent function. Now, this is same case with slices as well, which we have already discussed when we were discussing about slices. So, this is to be noted that whenever you are using map or slices, you need to take very good amount of care of what you are passing into the function, and if you do want to change the value and get the value updated in the original function or original place or not, because this is a very let's say crucial point when you work on a production app and you pass a map to a function and you change values there, and then the similar change is affected in the main function, and you sort of get mixed that how did it change. So you need to take care of slices and maps. But yes, when you use arrays or structure, those are not actually pointer passing. They're actually the value mapping. So it will copy the complete value set to the child function or the calling function. So that can be also disastrous in case your array or your structure is very large in size. So it will create a complete new set of memory and creating double memory of it. So you need to take care of these examples and note where you need to use reference or where you need to use non-reference values to it. But yes, map and slices will not have any non-referential passing. It will always have a reference getting passed. But yes, in array and struct, you can definitely use the and sign to pass the address of it and then dereference the structure and dereference the variable and use it wherever you want. So that can be done there. But that depends on your case and should be analyzed and taken care of. So that's all on pointers. Thank you for watching the video. Please do not forget to like, share and subscribe to our YouTube channel. Also press the bell icon so that you don't miss on any new notifications. Also do comment us below on any feedbacks or any new tutorials that you want us to do.